Come on. We're live. Okay, so here we go. So today's notes, 10:25. We really are talking about exponential functions. What makes exponential function is that the exponent is the variable, right? Or the unknown. So if we have some y equals some ab to the x power, it's the x power. It's the variable, okay? So things are going to grow exponentially. And so you've got a little formula here. A of 0 is the beginning amount. A of 0 is the beginning. You have to have the 1. R is your rate, which is in terms of percentage most of the time. And x is our exponent. In terms of years sometimes, depends on the problem. But oftentimes it's in terms of years. So if I use my Desmos, you have to have the 1 there, okay? Real quick story why you have to have the 1. I mean, you guys will get it. You got $10,000, Jose. You put it in the bank. You got $10,000 you put in the bank. You come back in 10 years, and they go, great job, you just earned $200. You just earned $200. They give you $200. What's wrong with that picture? You didn't get your $10,000 back, right? All you got was so. Yes, you gotta have the 1. You know what the 1 does? It gets back your original 100% of your investment, right? That's why the 1 is so important, right? Without that 1, all you're gonna get is your interest, and they're gonna keep the rest. Okay, so if I put this on Desmos, I mean it's super easy if you put this on Desmos. You guys kind of see the idea. Desmos, I like Desmos. Gonna go y equals my 4 parentheses 1.12 to the power of x. And there it is. Okay. So I look at the curve. What do you see about the rate of growth? What do you see about the rate of growth? The rate. What's the slope? What do you see with the slope?
It goes up.
How steep is the graph?
It's not
How
it changes as the x.
is it getting steeper?
Yeah.
So if I go like this, look at that. Whee! That's a bad thing, see? In perspective to like human terms, here was the earth for many, many, many years. And then we hit the Industrial Revolution. We learned how to take care of ourselves. And now I look at the exponential growth. Ooh, man. Scary, huh? So let's graph this. 1, 2, 3, 4. And our graphs do not have to be perfect. I always want to have my y-intercept. And then the shape of the graph is like a J, and it increases steadily, okay? What's the growth rate? Well, the growth rate is 0.12 or 12%. You can see that, right? You can see the 12%. So that's 12% growth. The curve gets steadily steeper and steeper and steeper, okay? What's the y-intercept? The y-intercept is at the 0.04 because that's your starting point. That's exponential growth. That's growth. Now let's look at exponential decay. So I look at the next one, and I look at it in Desmos, and we're going to go our 100 times my 0.80 to the x power. It looks like this. Looks like this. All right. And if I were to flatten this curve out a little bit, let's see if I can make this a little better. Here's a better picture of it, right? And it's going less and less and less and less. And it never reaches 0, but it bottoms out, okay? So let's...
Why is the scale on your y-axis x-axis?
Just to show, because it drops. Great question. So it has to do with almost this half-life. It starts at 100, it goes to 50 pretty quickly, right? Within one cycle.
Okay.
And then it goes from 50 to 25, right? Within one cycle, okay? So let's go ahead and put that in. So we're going to start at 100, right? And again, I don't have to perfect, it just has to have the right shape and the right y-intercept. And we're going to add one more thing, okay? Jose?
Yeah.
You know what? I'll pick on Carly today. I won't pick on Jose, okay?
What?
Carly, stand up right here. Stand just right here.
No. I don't remember this.
Okay. Face the door. Okay, walk halfway. Walk halfway. This is so much fun. Walk halfway. You know where we're going with this, aren't you?
Yeah.
Go walk halfway. Walk halfway. Is she ever going to get to the door?
No.
No, never get to the door. You guys agree? So what we're going to do, thanks Carly, did that wake you up a little bit?
I've been awake.
Okay, so we're going to put in what I call asymptotes, right? You guys remember that? So these are like invisible lines, but it's a line, it's like a borderline, okay? So it's called an asymptote. Sounds like a funny word, but y equals 0, and here we also have an asymptote, y equals 0, okay? So then if we go to our domain and range, the domain of this is forever. I mean, even though it's going up, it's always going over. The domain is going to be x equals all real numbers, because it goes, the width of this graph is forever, and the domain of the other one, the domain of this one's same, isn't it? It's forever wide. But what about the range? What about the range? Perfect. Greater than, but not equal, right? Perfect. So it's y is greater than 0, and the same thing with this one. Y is going to be greater than 0, okay? Thumbs up. Pretty easy. We saw this in Algebra 2, right? So this, I knew this was going to be an easy day for you, okay? Now, example 3. Let's actually use this. So radioactive isotope decays at a rate of 15% per day. So every day we lose 15% of what we have, and then 15% of that, and then 50. So it's slowly it's decaying. So I'm going to use my formula. I'm going to use my formula that I have up above, but I'll change it slightly. I'll go a of t, a0, 1 plus or minus r to the t power. It's basically the same formula, okay? Amount over time. Amount over time. A of t, amount over time, okay? So if I want an equation for this example, let's see what I'll have. I'll have a of t equals a of 0 is my beginning amount, just 40 kilograms. 1, and it's decay, so minus, right? 15% is the same as 0.15 because we moved the decimal 2 places, right? So 0.15 to the t power. So I have an equation for that. So my decay rate is 15%. The decay rate above is 20%. Does that make sense? This one's a decay of 20% because 80% is left over. Right? Now, let's keep going with this. Let's use our formula. So we want to know how much is left in 6 days. So we'll just go, okay, we'll go a of 6. Amount after 6 is equal to 40 times 1 minus 0.015 to the 6th power. And of course, you can make that 0.85 if you want to.
Is that 0.1?
Oh my gosh. Yes, thank you, Ellie. I'm so glad you're here. Between you and Lauren, you guys catch all my dumb mistakes. Thank you. So, Or you guys could have written this same equation as 40 times 0.85 to the t. Either way. But I'm just going to use my calculator to get the answer. All right, so I'm going to go 40 times 0.85 to the 6th power, and I get an answer about 15.08. Okay, 15.08. And that's kilograms of whatever nasty stuff this is. Pretty easy. Yeah,
How do
Ellie?
you get the 0.85?
Oh, I just went 1 minus 15.15. Yeah. So you have to be careful because when you see a number like this doesn't tell you how much it decayed by. Decayed by 15. Because you went from 100% to 85, so you have lost 15%. Means you keep 85%. Okay. How you doing? Good. Turn the page. All right, now negative exponents. Okay, do you guys remember this? If it's a negative exponent, you're on the wrong side of the fraction. Right? Okay, negative you guys remember this? Negative exponents. It's on the top, it comes down. Negative exponents on the bottom come up. Okay, you guys remember that? Okay. So this should be easy. I think today's kind of a review of what we've learned before. So the first thing I'm going to do to simplify this first one, fraction bar. I'm just going to move everything that has a negative exponent. This is going to come down. 3 squared. This one's going to come down. X to the 5. When you move it, it becomes positive. Anything to the 0 power is going to be 1, but hold on, I've got y squared times 1. This 5 stays where it's at. X to the negative 2 comes up. Y to the negative 4 comes up to positive 4. And the Z3 stays. Okay, I'll do it again. I'll show you what I did, okay? I'll show it again, okay? Anything with a negative exponent moves. Boom, came down, right? This one came down. This one went up. This one came up. This one stayed where it's at. That becomes the number 1. And the 3 comes down also. 3. Okay, everybody got it? Just move. That's all I'm doing. Now let's tidy it up and see what I get. Okay, so I'm going to have a 3 squared is 9 times 5 is 45. You okay with that? 9 times 5. I'll have a y to the 6th. 2 of these x's will cancel 2 of these x's, and I have a x to the 3rd. A z to the 3rd stays down all by itself. I can choose to keep this 1 up here if I want it, but I don't need the 1, but there it is. Remember that from last year? Yep. All right. All right. Now, on B, probably the easiest, there's a couple ways to do B. I think the easiest way to do B is just to multiply exponents first. And then I'm just going to multiply, I'll get an a to the positive 6, b to the negative 8. I'll do that first and then I'll move them. Okay? That might be the easiest way to do it. So let's go ahead and do this. So I'm going to have a multiply it through of a to the positive 6 over b to the negative 8. This is an easy one, huh? And then I'll just bring the b to the negative 8 up. I'll have a 6 times b to the 8th. Pretty easy. Brittany's tired today, aren't you? You know. All right, C. Couple ways to do it. Let's do it the easiest way. Honestly, there's a bunch of ways to do it, but let's do it the easiest way. I'm going to write 4 to the negative 1, x to the positive 3, and y to the negative 1. I think that's the easiest way to tackle this one. You guys okay with that? I'm going to have a 1 over 4 to the 1. My x to the third, I put 1 over just because I'm making a fraction. That's the only reason I put the 1. And y on the bottom. So I brought the y down. X stayed up. 4 came down. So I would have basically an x cubed over a 4y. And again, you can keep the 1 there if you want to, but I don't really care about the 1. All right, D is just, let me rewrite D because I can't type these things very well. All right. I'm going to do this one different. I'm going to do this one different, okay? I'll wait till you're watching. I'll let everybody watch. With a fraction, here's the negative exponent, right? I'm just going to take and switch this fraction because that's going to go up and that's going to go down and that applies to negative. You forget that. Same thing here. This is negative. I'm just going to flip those. And now it applies to negative. I can bring it in, makes it negative 4, it brings it down. But if they're negative exponent fractions, you can just flip your fraction first. It's a nice trick. It works. It makes it easier, I think. So I'm going to apply my negative first and do this. I'm going to rewrite this as a over b squared times b over a squared cubed. Then I'm going to have, if I could squish it in here, a squared b to the 4th times b to the 3rd over a 6. I really had to squish it in there. And then 2 of these a's cancel 2 of these a's, so I'd have a to the 4 on the bottom. 3 of these b's cancel 3 of these b's. I'm left with a b on the bottom. What's left on top has to be a 1. What did you think about that one? These are tricky. Here's what I did when I was your age. I always did things the hard way. I could always get the answer. But after practice, and doing this for years and years and years, I always try to find the easy. Okay, so now.
Can you go through the pencil you're looking?
Yeah, I sure can. So let me multiply it out for you, Ellie. I think it'd be easier to see if I multiply it out. I kind of didn't do that, but if I were to go from here, and I'd go a squared b cubed over a6 b4. All right. 2 of these cancel 2 of these, right? 3 of these cancel 3 of these. But I just did, instead of doing that, I just simplified across, right? Because I knew that there's so many on top, so many on bottom, so many on the top, so many on the bottom. And I just skipped a step from multiplying it out, okay? Does that help? I just cross-simplified. I guess, okay, watch this. Right? Would it be easier just to do this? Instead of multiplying it through, right? It's the same process. I'm cross-reducing, okay? Did I answer that okay, Ellie? Okay, good. All right, now the last 2 are a little bit different, okay? They're both, okay, x to the 5th and x to the negative 2. They're both being divided by x negative 3. They both are. So I'm going to rewrite it as 2 different fractions. x5 over x negative 3 plus x negative 2 over x negative 3. Okay? They're both being divided by x negative 3. So let's make them into 2 separate fractions. Now I'm going to move my negative exponents, right? Hey guys. So I'm going to have a x5 times x3 plus x3 over x2. Thank you.
Yep.
And then if you guys want to grab the notes.
Oh, thank you.
No, that's right there.
Okay.
Yeah, right there. Yeah, thanks, guys. And then finally, I'll simplify that. X8, thanks, Kai. Just throw, yeah, X8 plus X. Okay, now F looks really easy, but it's kind of complicated. I'll go through it slowly, okay? Do you remember doing this?
Yeah, a little bit.
Yeah. All right, so F looks really easy, but it's a little complicated because of the plus sign. If there aren't plus sign, you can't add them because they're different. So I'm going to start out F like this. 1 over A plus 1 over B to the negative 1. Okay, that's all I did. So all I did is I applied those two negative exponents, okay? That's all I did. And there's an invisible 1 there and 1 there, but I don't really need it, okay? Everybody okay with that first step? 1 over, 1 over. Now, I want to add these, but you can't add them because they don't have the same denominator. So I'm just going to multiply this one by B over B and this one by A over A, and then I'd have a denominator, okay? I need a common denominator, so is that it? Holy cow, you guys. Okay, there's the homework. Wow, where'd all the fun go, huh? Okay, I'll show you the rest of this one tomorrow.